Good morning and welcome to the Andrew Alliance webinar hosted by Appleton Woods. Thank you very much for signing up. It's great to welcome you all here. My name's Luke Housley and I'm the Sales and Marketing Manager here at Appleton Woods. If you don't know Appleton Woods, if you haven't heard of us, we're a family-run business based in Birmingham and we supply laboratory consumables, reagents and equipment, which now includes, I'm pleased to say, automation, which is due to our partnership with Andrew Alliance. So as we've seen over the last 12 months, automation has played a critical role in COVID labs, but this instrument we're going to show today, or my colleague Jasper is going to show, is a very versatile piece of kit that can be used in most applications within the laboratory and any laboratory. So without further ado, I'll hand over to Jasper from Andrew Alliance to talk us through the benefits of the Andrew Plus, and then we'll have some questions at the end. So over to you, Jasper.
Sounds good. Thanks, Luke, for the introductions. Really happy to be here and be part of the exchanges with Appleton Woods. It makes a lot of sense that our product offering kind of converges, and you'll understand exactly how and why. So as presented, I'm Jasper Eaton. I'm European Sales Manager at Andrew Alliance, now a waters company, as a matter of fact. Andrew Alliance was actually founded back in 2011, and we launched the first product of Andrew, the liquid handling robot that's sitting next to me here, back in 2013, as it were. So we've got a little bit of experience now over the years with liquid handling instrumentation. And now we're taking that one step further with the launch of the Andrew Plus instrument. So not the Andrew instrument, but the Andrew Plus instrument that was released back in February of 2019, along with a whole connected lab ecosystem that we call OneLab. That's essentially software in the cloud, and that helps us really organize our lab workspace. So my objective here today, in conjunction with Appleton Woods, is to present the instrument as a versatile laboratory tool, as Luke presented it initially. And I'll do that in two parts, the first of which will be purely hardware, right? And I'll get this instrument running live right here, right now for you guys today. He's on pause, as you can probably tell. I'm ready to just get him up and running and kind of talk about the hardware side of things so that you can understand essentially what you're seeing in front of my bench, in front of you right now on my bench. That's part one. Part two, I'll go over to sharing my screen so that you can understand how I program this and what I mean by connected laboratory software. So really going full circle from executing a run with the instrument, all that's incorporated with that from a hardware perspective, coming full circle through software to writing a protocol together, talking about specific applications, and then executing that protocol, and we'll really come full circle from there. So without further ado, I'll go ahead and launch the Andrew Plus instrument. But first, hey, I like the pressure build up. First, you need to know a few little things about the instrument and how it functions. The first of which is actually would seem obvious to most, is the use of liquid handling pipettes. So these are electronic pipettes that are manufactured by market leader Sartorius, and they're completely used in full autonomy by the Andrew Plus instrument, thanks to a couple things that are built into this pipette that make it very unique when it comes to liquid handling automation today. The first of which is updated firmware inside this pipette that allows for communication with the instrument. And of course, the second of which is the Bluetooth connection that allows the instrument to send commands directly to the pipette. So anything that's volume changes, aspiration, dispensing speeds, mixing steps, tip ejections, insertions, all of that is being controlled directly by the robot via Bluetooth towards the pipette. So this is the workhorse of the instrument, right? In terms of laboratory precision, reproducibility, and everything that you need when it comes to liquid handling automation is actually happening with this pipette. By the way, you can use these pipettes manually as if they were, normal pipettes. They don't have to be fancier than they are. They're just capable of being connected to the robot if you need. So full manual is possible as well. All we do to make them compatible with the instrument physically is just add a little adapter. As you can tell here, the instrument has grabbed the pipette through the adapter. So that's the pipettes. Second of all, and just as important, is the bench space that you're seeing in front of me here. And I'll get the instrument running in a second so that you can see what that really looks like. These individual blocks are what we call dominoes. So these dominoes really create the interface between the instrument that has a camera and a specific labware or consumable that is compatible with the Domino. We make Dominoes compatible with many different consumables. We do not sell consumables as Andrew Alliance, and that's the whole point of a discussion with Appleton Woods as well. We can certainly make consumables compatible with all Appleton Woods consumables, right? So we make these Dominoes in order to have third-party consumables be compatible without having to think about it with Andrew Plus automation. These Dominoes essentially slide into place one next to the other magnetically. And so you build out a very flexible bench space just like that. As you can kind of tell here, they just snap into place here magnetically. And we can have up to 11 positions of these, which gives a lot of flexibility in terms of which dominoes you can place. We have a whole catalog and where you place them. So up to 11 dominoes. So the bench space that you're looking at right now is specific to the demo that I want to run today and that I've started running for you guys today. But it could look very much different from one protocol to the next, from one day to the next. And that's really part of the whole flexibility of the Andrew Plus system. So I'm going to go click on resume here physically on the instrument so that he can pick up his run from where I left off. It's just right after a bench scan, he's starting to pipette. So I'm going to go ahead and click on resume and cover a couple points as he runs. So when I mention full autonomy of these pipettes, I mean it. He's able to, I say he, but it's really an it, it's a robot. Andrew Plus is able to use these pipettes fully automatically. So that's all of the tip insertions, volume changes, as I mentioned, tip ejections, insertions, aspiration speeds, mixing, up and down mixing, and using these pipettes just like you and I would be. To program that, and I'll run it. I'll run by the software immediately after this this hardware presentation to show you exactly what I mean. But it's really quite intuitive to do so. You don't really have to know anything about automation in order for the instrument to be able to work for you and not against you. That's really our objective here. So that leads me to an important point regarding where this product is positioned within the market, and I think it's important for everyone to know. We're not looking to be the high throughput, full automation system that can do everything from start to finish. We're really looking to be the intermediary between someone doing this, so standard pipetting, whether that's single 8-channel or even 12-channel pipetting, right? So from manual workflows, being the intermediary between manual workflows and those much higher throughput systems. We identified that there was really not that much in between, and we wanted to make it absolutely dead simple for anyone to just walk up to automation and be able to start using it. And you'll see exactly what I mean when I start sharing my screen with the software. You don't have to be a specialist in, you don't have to be a specialist in automation. You don't have to be a programming guru for C++ or Python or anything of the sort. You just need to know your science, and the Andrew Plus will be an extra set of hands to actually execute your science in the lab. Make it really easy for you to do so. So here I'm running a serial dilution physically with the Andrew Plus instrument. So he's using the proper channels, the proper pipettes with the proper number of channels to do that in the most efficient way possible based on what he has available. In this case, to prepare a serial dilution, he's taken a 1.2 ml pipette and dispensed out buffer before switching over to a different kind of pipette that'll be more precise in the lower volume ranges in order to create a serial dilution within this 96 well plate. And you might have noticed something. Dominoes are actually much more than just standard consumable holders. They can be functional consumable holders, just like you're seeing here with the shaker device. So I'm actually gonna go here and change my camera so that you can see something a bit more closely. The instrument here is actually going to work with functional devices that we call Device Plus. So they're more than just dominoes, like a shaker or even a Peltier that's sitting right here next to it. So I'll get into a little bit more detail about these functional dominoes, or that we call devices, as I run through the software in just a moment. So as you'll see here, he's actually going to create a serial dilution while the shaker is shaking, if I may, right? So he's really going to be able to optimize standard serial dilutions as an example, right? This is just one example that we can run into for automation with the Andrew Plus instrument. So that brings me to another interesting hardware point that everyone should know about. The pipettes that the instrument is capable of working with cover the volume range of 0.2 microliters all the way up to 10 milliliters. And this is quite unique in the automation genre. We really use the single channel pipettes from Sartorius, and they're the only ones that can actually be automated, to my knowledge, with instrumentation as it stands today. So that actually diversifies the range of applications, because we can go into cell culture, media preparation applications, for example. We can start talking about MIDI or even potentially maxi prep for RNA, DNA separation from plasmids, for example, using those much larger volume pipettes like the 5 ml or 10 ml pipettes. So the instrument is doing his thing here, and just afterwards, he's actually going to give me a log report of everything that happens, and that'll be a great transition into the software as I let him complete the run here. Just before I do that though, you'll notice that the instrument is actually using his camera progressively to identify where these dominoes are actually placed. So he's reading the QR codes that I showed you earlier of each of these dominoes in order to know where they are and in order to know exactly what consumable he's working with at any given position. So a consumable has been specifically designed for a domino. No, the other way around. The domino has been specifically designed for a consumable in order to optimize it seamlessly for automation with the Andrew Plus instrument. So there we go. My run has now been completed. I'll have the log report directly on my screen in a moment. I'll just show you the end result of this serial dilution here. In a 96 well plate, we have a serial dilution that's been properly homogenized. Now I will say that this is of course just with water and some colored rouge ponceau, some dye, some red dye. There we go, for demo purposes. I will then switch around my camera and start sharing my screen, which should allow you to pin my screen or pin my camera depending on what you want to see. So you can click on the 3 little dots for those of you that are with us live today on my camera or on my screen once I start sharing it to follow what you want to follow. I would highly recommend looking at my screen and not my face. It'll be more interesting, I promise. So here we go. Can my friends at Appleton Woods please confirm that you can see my screen? You should be seeing the Andrew Plus virtual demo screen on my software as it stands.
Yes, we can see that, Jasper. Thank you.
Great. Thank you, Luke. So this is actually an interesting transition into the software, and I like presenting it this way because you really see this, the seamless integration between what hardware has just executed and what the software is picking up and going to provide as information that you can always use downstream. So this is the log report that'll give you everything you need to know about each of your protocols. Essentially the who, the what, the when, the where, and the how. Everything will be in this log report and automatically stored and saved in OneLab. So OneLab is the name of the software if you haven't gathered that by now. And here's my log report. I know who signed in, so it was myself, luckily. I know who created the protocol, it was also me. When it was created, the date it was last modified, the version that it's on. And of course, as I scroll down here, I know which instrument was used in order to execute that protocol. I can go down to the pipettes, their serial numbers, when they were last calibrated, know exactly which consumables were used, what solvents, what buffers, what sample numbers. I'd be able to extract all of this data as a CSV file or an Excel file, for example, that I could then communicate or copy and paste with my LIMS or my ELN as here's what happened during this run and extract that information. Sample positions in a well plate, concentrations, what they were mixed with, all of that information is here, in addition to the actual protocol steps with timestamps of exactly what happened and how the instrument was programmed to do those steps. So you'll see here step-by-step progress of the protocol that was just run. And I'll go ahead now and release this report, which brings me a little bit into the compliance part of the software, because as the person that executed this run, I can then release this report. And even if I'm a lab administrator, I can then sign, so electronically sign the protocol with my username and password to OneLab so that it'll be a full trace that has been released, logged, and signed for full compliance. So done, validated. Go ahead and release that experiment report. So the full traceability and compliance is actually happening everywhere within OneLab behind the scenes. You don't have to use it if you don't need to, but it is there at any given point. I can then print this protocol and just have that protocol report be available to me as a PDF if I want. I'll go back to OneLab Home. And this gives me a few moments to step back from what you just saw and really present OneLab as the general software that it is. Keep in mind here that OneLab is not meant to be specifically a software designed for programming the Andrew Plus instrument. To get that out of our heads as we run through the software here, the software is really meant to be kind of like that overarching lab notebook that allows for three main things. Protocol design, we'll call it universal protocol design, whether or not you have some form of automation to execute your protocol or not. You have the ability to share those protocols within the lab, within your lab, with each of the different lab members that are present in your lab and have been officially invited and accepted into the lab. And of course, you'll be able to have all of the log reports that I just showed you of experiment execution. So from those three aspects, OneLab is actually a more overarching software that really allows for universal protocol design, sharing, and traceability of exactly what happened within your lab space, whether or not automation was actually part of that entire workflow from start to finish, right? So just to give you a few tidbits about how that works, I'm part of the sales lab here at Andrew Alliance, and there are 28 different members within this lab, and each of us has different access rights to be within the lab. Whether we're lab administrators, expert users, or simple operators, we each have different rights to do certain things. Operator, for example, can only click on the big green execute button, can't change protocols, can't invite new members, and that's it. Right? So a lab administrator, on the other hand, can really do everything within the lab, sign protocols, release them, etc. I can invite new members as a lab administrator as well in order to bring them into my lab. Now, moving on, this actually brings up a very important topic about what the software is and how it works. You might have noticed from the beginning that I'm actually on onelab.andrewalliance.com. That actually means that OneLab is cloud software that can be accessed from anywhere. So I'm here in Paris, by the way. Hello from Paris. OneLab can be accessed from anywhere directly via our cloud. You have your own little private part of our cloud on which you can run your own version of OneLab. So not version, but your own OneLab workspace, if you will, that Andrew Alliance or even Appleton Woods or Waters or anyone else does not have access to. It's just as protected as your bank account information, for example, with HTTPS. That's just one of the ways to deploy OneLab or to use OneLab is on our public servers. It just makes sense. It's easy. It's protected. But there are other ways. If ever you're in a specifically compliant necessary environment, or you have very, very sensitive IT departments that require specific controls over any software that is being used within your company. There are different ways to deploy OneLab if the cloud does not work for you. Moving on in the software, and we'll really come full circle, trust me, to how I actually managed to run the instrument. Moving on in the software, you'll see here that I'm on my home page. Quick access to certain protocols that I want to have, that I want to know more about, or that I want to edit or tweak. I can have a deeper view of everything that's going on within my lab by going to my projects tab at the very top here and identifying each of the different workspaces in which we have various protocols or that all have the same topic, for example. Next, these are just folders, like folders that you would use on your Windows computer, on your Mac computer, exactly the same thing. Devices is where everything kind of comes together when I talk about this connected ecosystem of the lab. It's essentially Internet of Things for the lab, where we have many different devices that are all communicating with each other through this larger ecosystem that is OneLab, basically. So we have devices here like the Andrew Plus instrument. I have a couple of these here in Paris. There are more that are, of course, throughout the world, in the United States, for example, with my colleagues like Tom here. This is his instrument, and I'm seeing everything in real time about his instrument. So I know when it was last installed, maybe the last time a new firmware was updated. I know which pipettes he has available and ready to go on the arm of his robot. what their serial numbers are. For example, if I want to have that trace log, I'll know the usage log of that instrument, everything that happened with that instrument over the course of its lifetime. So here again, really pinpointing the overarching point of OneLab, which is traceability and compliance, knowing everything that happened within the lab from start to finish. Next, and this is actually quite important from an application standpoint, all I've talked about so far is automation, hardware, and writing protocols and all of that. But which protocols do we want to write? Literally, it could be many different things. We've started off with general liquid handling, like serial dilution, standard curve creations, aliquoting, pooling. All of these are very classic end-to-end applications that users would be doing manually. But we can take this one step further, of course, and I'll introduce the OneLab Public Cloud Library, where you have access to a little bit more complex protocols eventually that'll give you templates. These are pre-written templates of protocols that you can just copy to your OneLab workspace and use as a great starting point for automating them downstream. Some of them have been already validated by ourselves and our partners for the Andrew Plus instrument, or even for our other pipetting solution called Pipette Plus, and I'll explain that in a moment as well. It is a viable option. Some of them are just there to guide you with pre-written protocols so that you don't have to write anything from scratch. Just use them as your template, change them if you need, optimize them for your workflow in particular, change the samples, sample numbers, etc. So for example, we can go into much more complex protocols like Accutag amino acid sample preparation for from the Waters Corporation, for example, which is another company now. We can get into something that I mentioned earlier with extra MIDI prep, so for RNA, DNA, plasmid preparation with our partners from Ashray Nagel. We can prepare the detection of COVID-19, and how accurate is that for these days? We can help you by creating a template for that. And as I scroll down here, we can see everything else that we have that's pre-written, ready to go for you as templates. So you can just copy these to your OneLab workspace and start working with them from there. Now, getting into the funner part of the presentation here is actually designing a protocol. This is where everything that I've just mentioned will kind of come to life, and you'll see how simple it is for anyone to just walk up to the system. If they want to use a template, great. The template will just come out and be exactly what you're seeing on my screen here, except with stuff on it, very in layman's terms. Here I have a big white blank bench space on which I can do what I please. I'm the specialist, I'm the lab technician, I'm the scientist, I'm the person that needs to create the run or that needs to automate something. I know what I need to do. And so here we're trying to make it as simple as possible for anyone that knows what they need to do to be able to translate it towards automation or have it guide any other user to do it the way that you want it to be done. So this big white bench space here allows you to do that by, first of all, selecting specific kinds of labware that you already use in your lab, for example, or by copying and pasting data of information like samples, specific samples that are in specific tubes, just by copying and pasting them directly onto the workspace. So I'll kind of do it the simple way here so that you can see exactly what I mean. I'll go ahead and add some labware to my bench space. I can choose from this long list of consumables that we've integrated into OneLab over the couple years of its lifetime. I have access to pretty much anything, plates, tubes, vials, large bottles, you name it. We will likely have it in the software here, and we're working on developing a lot more based on popular request by our customers. For example, if they want to integrate a specific labware and use it within OneLab, they can just ask us and we will integrate it. And that will certainly be the case for consumables from Appleton Woods. So here I can just scroll down and kind of use some of the filters that I have in OneLab in order to pinpoint exactly what I'm looking for. If I know, for example, that I'm already writing a run for the Andrew Plus instrument, which I am, at least for today, I can go ahead and use one of the filters down here on the left and say, hey, OneLab, please show me all of the consumables that are today compatible with my Andrew Plus robot. And so OneLab, with a check of a box here, will show you, all right, here are the consumables that have a domino. So if you can see my video as well, I'm holding up a domino. When you see a consumable that's on my screen, there, that means that it has a Domino, and that automatically makes it fully compatible with the Andrew Plus instrument, to be 100% clear. Anything that's not in this list is not compatible with Andrew Plus, but we can make it compatible, as I was saying, with our custom Domino process. We are not consumable vendors. We make Dominoes for consumables in order for the user to not have to worry about it themselves when they want to automate the use of a consumable, if that makes sense. So I can go down here and scroll and see everything that we've already got: tubes, plates, vials, microtubes, you name it, it will likely be here. We can go down to the details of that specific microplate or tube and click on the manufacturer data page, and that'll bring me directly to the manufacturer website in order to allow me to order more. Go ahead and add that lever to my list, my frequently used items, pop them onto my shopping list here. Make my little shopping list. I'll go ahead and add these to my bench space. And everything I have here is a visual representation of everything that I will be using as the lab technician, as the scientist, to create my protocol. So very visually, this is literally sitting in front of your bench. What will you want to do with it? So I'm going to want to have something to put inside the tube. So I'm going to go ahead here and add some solution into my 50 ml centrifuge tube. Go ahead and add some reagent. Here I've got quite a few reagents that are already in here because I've been working on it for a while. You can always create new reagents for your lab as you go. So I've now just filled my Falcon tube with some substance that I can then work with. And here, let's fill my Fisher tube here with some sample. And that allows me to mention something about sample tracking and traceability within OneLab, because we can essentially give a sample ID, and have OneLab track that sample over the course of its lifetime within OneLab and within the experiments that we're executing in OneLab, in order to know what happened to it. And I can then click on my target labware, in this case, my 96 well plate. I think you see where I'm going with this. 96 well plate can be my target labware. That will then allow me to extract specific information of everything that's happening inside my plate, or everything that has happened inside my plate at the end. So I'll know exactly which samples are in which positions, what concentrations they're at, what they've been mixed with, etc., and have that be extracted as a CSV file. All right, so now I think you're seeing where I'm going with this next step here. I'm going to drag and drop in order to create a pipetting step. So you don't need to be a rocket scientist. You don't need to know how to program. You just need to know how to do your science, how to do your drag and drop, your copy and paste, and your protocol will automatically come to life for automation, because OneLab and Andrew Plus will do the rest. So here, how much volume do I want to put in my little multi-channel reservoir here? Any volume you'd like. The robot will automatically adapt the right pipette for you. In this case, let's fill it up with 10 milliliters. It's a good use case for the large volume pipette. And everything you're seeing in the window here that I'm showing on my screen are all of the parameters that are associated with that pipetting step that we've just dragged and dropped to create, right? So it's everything that you would be doing naturally in your head as you were using the pipette. You're experts. How would you be doing that step? Forward pipetting, reverse pipetting maybe, if it's something a bit more complex. Doing a blowout, aspirating or dispensing a little bit more slowly or a bit faster. Adding some air cushions. This is actually something that you can't do manually, otherwise your volumes would be completely off. The robot knows how to add an air cushion before or after an aspiration in order to optimize pipetting for viscous or eventually volatile solutions. The robot here is in the advanced section. We're talking more about automation. The robot here is capable of following liquid levels as it aspirates and as it dispenses, based on a starting volume that has been given to it. So as we say in a tube that there's 50 ml, he'll be able to follow that liquid as he aspirates from it over the course of many different pipetting steps of an experiment, for example. And the same goes for the destination. He'll know where the liquid level is at based on that first starting volume that we gave. We can very well say on the fly, hey, Andrew, or operator, whoever it may be, don't touch the liquid that's already inside my consumable. I don't want there to be cross-contaminations, for example, or I just want to save on tips. On the fly, that's an option. tip changes during the pipetting step. If there are multiple steps that need to happen, we can avoid having tip changes if we don't need to. Same sample to an empty plate, don't change tips. And of course, last but not least, when it comes to pipetting, is mixing. How do you want to mix? How many times do you want to mix? With what volume? Whether at your sources or at your destinations. So I'll go ahead and save that step. And you'll see, just like that, I've created a pipetting step that shows me my source, my destination, and automatically populates my list of pipetting steps within this protocol as we go. So next, go ahead and drag and drop my sample here. Same idea, same concept, drag, drop, choose a destination. Maybe we want to do triplicates here. Go ahead and save that selection, choose a volume, and I'm back on this same window. So how do you want to do this particular pipetting step? Okay, let's do that repetitively. So take up a large volume, 50, 50, 50. Normal speed. Let's go to the bottom at the destinations here. It's precious sample. And maybe we want to pre-mix my source in order to maybe resuspend what I'm working with or create a perfect dilution. Go ahead and save that step. And next, let's just do a drag drop here from my multi-channel reservoir source. Same thing, I choose my destinations and the robot will automatically be capable, and with the software, to identify which pipette is available and best adapted to do the particular step you're looking to achieve. So I'll go ahead and save that selection, specify my parameters, repetitive, on the fly, save. And just like that, I've written a couple pipetting steps that lead me to an eventual serial dilution if I want, or just as an example, right? I can take this one step further, of course. I mentioned that OneLab is universal protocol design software. There's a reason for that. OneLab can do much more than just do pipetting. All I've done so far within these first steps is where my arrow, where my pointer is pointing at right now, pipetting. We can take that a step further by helping you automate or helping you create concentration normalizations for DNA library preparation, for example, serial dilutions, as you saw. So I essentially use this little wizard here to create a serial dilution in a couple easy steps, drag, drop, select the volume that I want to achieve, the concentration that I want to achieve with my dilution factor, and the software will do the rest. That is to say, identify the right pipettes to use, calculate the volumes that need to be transferred, and where they need to be transferred. Next, I'll highlight 4 application-focused devices. I mentioned some of them with the hardware part of this presentation earlier on. The first of which is the Shaker Plus device that is actually capable of, as you guessed it, shaking. We're going to release a new version of the Shaker Plus that's actually shaking and heating at the same time if you need to do that. Next is heating and cooling with the Peltier Plus device that can actually achieve very low temperatures and very high temperatures, all with the same device. So this exists for PCR type microplates. It's the most common use case. So as you're seeing here, this is a PCR microplate that I've just placed here onto my Peltier Plus device. I'd be able to specify a desired temperature that needs to be achieved before or after, and placing the plate before or after that temperature has been achieved, for example. Next, applying a vacuum, which is something we do a lot for solid phase extraction workflows, most notably with our colleagues from Waters. Naturally speaking, for liquid chromatography workflows, this is a big one. We have a vacuum that is directly connected to a pump, and that will turn on and off automatically when connected to the cloud. So this is another device that we can fully automate with the use of Andrew Plus. Last but not least is certainly being able to apply a magnetic field, whether for 96 well PCR plate bead cleanup, or eventually for deep well plates, it's also possible, or even scaling that up further towards 50 ml Falcon tubes for the RNA and DNA separation protocol I talked to you about before with Maschmeyer-Nagel. So magnetic field bead separation is certainly possible in a fully automated way with the Andrew Plus. A couple things I have to admit we can't do. Centrifugation we cannot do, but it can still be programmed within OneLab, same as vortexing, which simply means that if we're automating this workflow and we arrive to a certain step that the instrument just can't do, OneLab will automatically pause the instrument, eventually send you an email if you want and say, hey, it's your turn to play. Go ahead and centrifuge this particular plate for 5 minutes at however many rotations per minute you need it to be. And then put the plate back on the instrument, click on resume, and the instrument will pick up where you left off. Maybe do the final pooling steps, taking the supernated of whatever's left, reallocating. Those steps can still be built into the workflow through OneLab, even if we can't automate it. And I really want to emphasize that point because it's true, and it really helps you have the traceability of what happened, even if everything is not fully automated. Of course, over time, we're looking to integrate more functional devices like these that will be directly communicating with OneLab, balances, centrifuges, PCR thermocyclers, whether they're first party from Andrew Alliance or eventually third party devices directly within the OneLab ecosystem, thanks to connected bridges, to get technical. Anyway, we know that there are some things that we cannot automate, but the goal of OneLab and this whole ecosystem is to be able to take a step back here and not necessarily have to automate everything. With that being said, we can very well add a user action. Maybe something special needs to happen. Maybe there needs to be a check at one point that the human needs to intervene on. We can perfectly well add a user action within the protocol that will, here again, pause the instrument, send you an email. He'll flash green, orange, or whatever you want and tell you, okay, it's your turn to play. You specified that there's a user action. Let's integrate that into the protocol. And last but not least, of course, a timer. So we can very well complexify these protocols. I've just selected shaking. It's the use case you just saw. Drag, drop, select a speed, select for how long. Go ahead and save that step, and that'll automatically start a timer and a start stop. And you can embed steps within this. And that's exactly what I did during my hardware presentation today. I created a serial dilution within my shaking step. All right, a couple things before I click on this execute button here. In terms of compliance, I keep hammering home this message because it's very important. We have protocol versioning that will allow us to see which protocol version I'm on, how many times that particular version has been run, executed, aborted, or anything of the sort, and have a log file with all of the changes that happened from the different operators, because I can have free text here and say, just made it, only version with sample first for my dilution, for example. Go ahead and save that comment. And in real time, the different users can comment on this particular version if they've changed something, if they're allowed to, obviously. Next up is the lock here. We have the ability to lock a protocol if we're a lab administrator or an expert user, which naturally allows for no one else to change the protocol. If you really need that version to be the final version that everyone else uses, this is really important. I can, of course, rename this protocol, export it, share it with my other lab members the way that I see fit. So next, I'll click on execute, but this protocol actually makes not very much sense. So I will go ahead and go back to the protocol that I just showed you from my homepage. It's the virtual demo. Here's what it looks like. This is exactly what you saw today with my serial dilution embedded into my shaking step. I'm on version 28 of this protocol. I keep tweaking it to adapt it to different situations for different customers. I'll go ahead and click on execute now, and you'll see exactly what happened literally 2 minutes before we all signed in today. When I click on execute, OneLab is going to communicate or talk with the different devices that it has available or not to execute particular runs, right? So in this case, he's talking to my Andrew Plus. I like to call him Jasper's Andrew Plus. It's mine. He's communicating with my Pipette Plus system, which is essentially a connected pipetting stand that's using exactly the same pipettes as Andrew Plus and that can be used manually. So these, right? Except you're the arm. So you are guided with the on-screen instructions and the pipette stand itself. So it's a smart stand that's communicating with OneLab in order to execute the protocol steps one after the other with simply the press of a button. Every step is done by pressing one single button. So no more fidgeting around with the volumes, the changing the parameters, or etc. All of that is already defined in OneLab, and OneLab is sending that information directly to the pipette via the Bluetooth stand. So it's a good option if you really need the traceability and the compliance within a lab space, maybe onboarding new members, have a complex protocol that maybe automation can't do, and you're just looking to have an easy way of integrating that traceability. Pipette Plus can be a more cost-effective solution, naturally, in that sense, and just help you half automate those runs. I like to call it half automation. And of course, the other solution here is Andrew Plus. He'll tell you exactly what he needs or what he has available for this particular run. You can go ahead and click on that, giving me a material list so that I can get set up and prepared as the technician. Click on continue, maybe set up some email alerts here so that he tells me when I have a user action or when he's going to be ready to, release that protocol. And everything you're seeing here should make this whole presentation come together, from actually writing a protocol to executing it and what that looks like. So this bird's eye view image is exactly what I would need to put in place as an operator to make sure that this protocol gets executed successfully with Andrew Plus. I need to put these dominoes in the correct positions with the correct consumables in the right spot, right? So here I just click on the domino positions 1, 2, 3, 4. They all snap into place magnetically, one to the other. So here's the domino for purple tips, which is actually a color code for the 1.2 ml tips that I'll need. These are naturally compatible with the 1.2 ml purple pipette. There's a color code there too. Just need to put these tips right into position 1. The domino will snap into place, and I just create my bench space as I go by popping the right dominoes into the right spot. This domino is kind of unique. It's red. It means that I need to validate a starting volume before the robot will go anywhere or do anything. So I just need to check my starting volumes within these Falcon tubes, for example, in position A1 and A2. Yep, all good. And once that's done, everything else is in the right spot. I can click on Start Experiment. In this case today, I won't, because we'll just come right back to where we started, and I don't want to be on a loop. But at this point, it does conclude my presentation of both hardware and software. If I were to click on the Start Experiment button, the robot would just start scanning my bench space, making sure that everything is in the right spot, connecting with the pipettes, and getting started automatically. So at this point, I'm happy to conclude my presentation and to answer any questions that are shot my way. So go for it. I'm happy to answer.
Yeah, thanks so much, Jasper. Much appreciated. I've of course seen this demo before, but I'm always amazed how clever the instrument is and actually how well you demonstrate it. So thank you so much. As mentioned at the start, we are recording, so if you prefer to put your questions into the chat or email them to me, please do. But while you're doing that, I'll just kick us off if that's okay, Jasper.
Of course.
We have a number of customers, or the vast majority of our customers, who have to work within microbiological safety cabinets. Is that a problem for the Andrew Plus? Could it be housed in a Class 2 cabinet, for example?
So generally speaking, it's not a problem, although we will have to be careful with the full dimensions and really check those comfortably before we invest time and effort into the system. We can, to give you an idea, we can fit about we can fit 2 rows of dominoes here and only have 54 centimeters of depth from the very back of the instrument to the very front of the second row of dominoes. 54 centimeters is actually not very deep when you consider the instrumentation itself, and fits under most standard cabinets. Of course, if you need all 11 dominoes, that would take up a lot more space in terms of depth, and we'd be at about 70 centimeters deep. Generally speaking, I would say yes, we can fit it into a cabinet. We just need to be careful about the depth that's available to us. Not so much the height, really the depth.
Okay, brilliant. That sounds great. Thank you. Any other questions from anyone?
Hi, Jasper. How easy is the instrument to maintain and service? Because obviously it's cloud-based, so you showed that you could obviously connect to instruments around the world. Would that be the same here? So if I purchased one of your systems, I could have it set up in my lab, and then you could literally log in from wherever you were if I was having technical issues?
Yeah, so we do that kind of differently because we're aware that there are some compliance difficulties. We don't actually have access to your OneLab workspace, but what we would have access to, if you give it to us, is actually through a different software. But you'd be easily able to extract log information of the instrument that we'd be able to read directly through OneLab. So you can invite us into your OneLab workspace, for example, our service and support team, and they would be able to extract that information and be able to use it to help you troubleshoot whichever problem you're facing virtually. So we don't have to come on site. So to answer your question from a technical perspective, the instrument itself doesn't actually need very much maintenance. It's really quite auto tuning. I don't know if that's the right word. It'll use its camera to recalibrate itself based on the dominoes that are placed in front of it. The pipettes themselves are calibrated by anyone that's certified to do so, whether it's Sartorius or maybe a third-party pipette calibration service. That's the workhorse of the lab right there, and the instrument will recalibrate itself. So no service contracts are particularly necessary. We'll just look at the log files of the instrument to see maybe what's up. If the instrument needs to come back to us at Andrew Alliance to be physically fixed, we would organize for that and do a quote as per if it's in extended warranty or if it's out of warranty, etc. Don't know if that answered the question, Stuart.
Yeah, perfect. Thanks.
Thanks, Stuart. Just one more for myself, Jasper, if that's okay.
Yeah,
the software looks incredibly intuitive, but also it looks like a really good tool for teaching or training. Is it free to use, and can anyone sign up? And could you envisage a lecturer standing at the front of a class actually using that to teach students?
Absolutely. I actually like that comment a lot. It's absolutely free to use. You can create an account right here, right now, today, and have the full functionality of the software. So everything that you saw today, up to, and I have to be very clear about this, up to the point where you click on execute, instead of having the Andrew Plus or the Pipette Plus system show up, because you won't have them, you'll just have the guided manual pipetting option that shows up with the free version. In order to have an Andrew Plus or a Pipette Plus, you need to have a device license. If you don't have a device license and they're not connected, OneLab will still work perfectly fine for guided execution and doing everything you saw today, but will just not connect to an instrument. That's the only difference with having free OneLab and having a device license. So for training, absolutely, just drag, drop, use the templates of the protocols that I showed today to as good starting points for showing people what's capable, what's possible with or without automation, actually.
Well, okay, brilliant. Yeah, I can envisage a lot of our customers will probably use that functionality, but then actually maybe later on invest in the hardware if they can. You know, it's a good starting point, isn't it?
It is, absolutely.
Brilliant. I can't see any more questions in the chat, so I think we'll draw it to a close. But I just wanted to thank you again, Jasper, and really appreciate your time and a fantastic demonstration. Thank you.
Of course, thanks a lot, Luke, and everyone from Appleton Woods, and those of you that were with us today. It was a pleasure. Have a good one, and we'll be in touch.